The silence of space hides more than we imagine. In Part 1, we uncovered the threats of gamma-ray bursts, rogue black holes, solar fury, and cosmic rays, dangers that remind us how fragile Earth truly is. But the story does not end there. Now, we go deeper. In this chapter, we explore the ghost particles, neutrinos, silent, countless, unstoppable. They may be the universe's earliest warnings. We then confront the fury of supernova, stellar explosions powerful enough to reshape galaxies, and trace the deadly shockwaves they send across the cosmos. Finally, we turn to the darkest predators of all, rogue black holes, invisible wanderers drifting through space, capable of tearing apart entire planetary systems without a sound. This is Part 2 of Quantum AI discovers hidden dangers in the universe. The deeper we look, the more the universe reveals and the more dangerous it becomes. The ghost particles, neutrinos, and early alarms. Among all cosmic messengers, none are stranger than neutrinos. They have almost no mass. They travel nearly at the speed of light. They barely interact with matter at all. In fact, trillions pass through your body every second, through your skin, through your bones, through the earth beneath your feet, and you never notice. For decades, neutrinos were dismissed as curiosities, invisible phantoms. But when AI began studying decades of neutrino data, it uncovered something astonishing. By cross-matching neutrino surges with astronomical events, the AI noticed a hidden sequence. Neutrino waves often arrive before the light of a supernova is seen. These ghost particles, escaping the core of a collapsing star, rush outward long before the explosion becomes visible. This means neutrinos are not just curiosities, they are warnings. With AI-powered detectors, humanity could one day receive hours, maybe even days of advance notice before a nearby star explodes. Enough time to prepare satellites, shield astronauts, or even shut down vulnerable power grids. But then came the anomalies. The AI found bursts of neutrinos that had no known source. No supernova, no flare, no gamma-ray burst. Just sudden floods of ghost particles arriving from the void. Some came from regions of deep space where galaxies are sparse. Some pulsed with haunting regularity, like the heartbeat of something unknown. Were they born from exotic dark matter interactions? From phenomena outside our current physics? Or from processes so distant their light will not reach us for millennia? The AI gave no interpretation, only data. But the message was implicit. The universe is sending signals we do not understand, and they are reaching us every moment. Supernova and galactic shockwaves. Nothing in the cosmos is as dramatic as a supernova. When a massive star dies, its core collapses, unleashing an explosion so powerful it can briefly outshine an entire galaxy. Supernova are the factories of the universe. They forge heavy elements, gold, iron, oxygen, and scatter them across space. Everything you are, everything on Earth, was built from atoms forged in such explosions billions of years ago. But the same events that give life can also take it away. If a supernova erupted within 50 light-years of Earth, its radiation could destroy our ozone layer, flood the planet with deadly ultraviolet light, and trigger a mass extinction. Scientists once reassured us, No nearby stars are close enough to pose such a threat. But the AI, analyzing stellar life cycles, tells a darker story. It identified stars closer than we believe that may collapse sooner than predicted. Among them is Betelgeuse, the red supergiant in Orion, glowing bright in winter skies. It is roughly 640 light-years away safe, by most estimates, but the AI's analysis of its unstable pulses suggests a star more fragile, more volatile, and more unpredictable than expected. And then came the evidence of past devastation. In Earth's oceans, buried in layers of ancient sediment, scientists discovered isotopes of iron-60, elements that could only have been created in nearby supernova. These layers are just a few million years old, meaning Earth has already endured cosmic shockwaves in its recent history. Did those explosions alter our climate? Did they influence evolution? Perhaps even reset the course of life itself? The AI suggests yes. And worse, it warns that the echoes of past supernova are still rippling across interstellar space. Invisible shockwaves, stretching light-years wide, sweeping silently through the galaxy. Earth may already be drifting through one. The Dark Wanderer's rogue black holes revisited. Black holes are often imagined as cosmic monsters, lurking at the hearts of galaxies, devouring stars and gas in violent displays of energy. But not all black holes remain chained to their birthplaces. Some are cast out, ejected by gravitational slingshots during galactic collisions, or by asymmetric supernova explosions. These are the rogue black holes, drifting silently through the interstellar void. For years, astronomers assumed such wanderers were rare, invisible, statistical oddities, but the AI's analysis of gravitational lensing data told a different story. It revealed hundreds of unexplained distortions in the light of background stars. Distortions too small for ordinary telescopes to notice, but clear to the machine's unblinking eye. The conclusion was chilling. Rogue black holes may be 10 times more common than previous estimates. The galaxy could be littered with them. Millions of dark wanderers, each carrying the power to reshape planetary systems. The danger they pose is subtle, silent, and terrifying. A rogue black hole passing within a few light years of the solar system would twist the outer Oort cloud, sending icy comets raining toward Earth. A closer encounter could distort planetary orbits, destabilize our fragile balance around the Sun. And the unthinkable, if one passed within a fraction of a light year, Earth itself could be torn from its orbit, cast into eternal darkness as a frozen, orphan world drifting through interstellar space. Unlike asteroids or comets, which can be tracked, a rogue black hole offers no warning, no light, no heat, no flare. Only the invisible ripple of gravity betrays its presence. By the time we noticed, it could already be too late. The AI simulations left researchers pale, for among the candidates it flagged was a suspicious gravitational anomaly moving slowly across the sky, in the outer regions of the Milky Way. The data was faint, the conclusion uncertain, but the possibility was there. One of these invisible predators might already be heading toward our neighborhood. We've seen ghost particles, supernova, and rogue black holes, but even these are only the surface. In Part 3, we face what lies deeper: dark matter, galactic collisions, and the end of everything we know.